Hello everyone, I'm Preetham from Sri Venkateswara College of Engineering, currently in the fourth year of my Computer Science and Engineering degree. I'll be presenting my technical seminar presentation, which is titled as Photorealistic Text-to-Image Diffusion Models with Deep Language Understanding. The table of contents are abstract, introduction, methodology, results, conclusions and limitations, and references. Coming to the abstract, so this paper is presented by the research team called Google Brain, which focuses on the deep learning models with focus especially on text-based image generation. So the paper that they have published is based on a deep learning model called Imagen, which is a text-to-image model with an unmatched degree of photorealism. So the paper also focuses on comparing it with other image generation models, and the result and end preferences according that have been presented in this paper is also given, and it also mentions the human preference of how the images are preferred, both in terms of sample quality and image text alignment. So coming to the introduction, in the past few years, there has been a significant amount of progress made in the field of AI and machine learning. In the few months that we have seen, we have there have been multiple milestones that have been achieved in the field of artificial intelligence. One of them is text-to-image generation, where a user can provide text inputs to an application and gain output of an image that is uh, that is based on the text inputted. So it is important to note that these models will will have to understand the English language from the text and combine the elements of the text generate uh, to generate accurate images. These models must also face challenges like capturing spatial relationships, understanding cardinality, and properly interpreting how words in the caption that have been that is being input by the human relate to one another. So they have to these models have to understand each part of the text description and generate the output. Yeah, the Imagen, that is the Google's diffusion model, uses diffusion mechanism and text encoders to generate photorealistic images, uh, provided the image caption. The paper also talks about Drawbench, that is a comprehensive and evaluation benchmark for the to evaluate how good the generated images is compared to others. So on Drawbench human evaluation, it is found that the results provided by Imagen outperforms all other work, including the work from DALI 2 from OpenAI, which was recently released. And it also talks about the human evaluation, and it is found that it is on par with the reference images in terms of image and caption alignment. So it means that the images, the caption provided is is on par with the image generated. So coming to the methodology, here we have a flowchart describing the overall methodology. So if we see here, we have a text prompt that is provided to the text encoder, we see that text prompt can be anything in the English language. So here it is an example about a golden retriever wearing a blue checkered beret and red dotted turtleneck. So the text is passed on to the encoder, and the text encoder provides the output to the image generator and other parts of the model, that is the super resolution models. So text encoding first the caption is input into a text encoder. The encoder converts the textual description to a numerical representation that encloses the semantic information within the text. So this means that the encoder takes the input as from the description provided, and converts it into and encloses the semantic information within the text. That is the how it has to be, how the text has to be understood, so that it can provide the related image. Next, the image generation model creates an image by using the diffusion model. So here we can see that the text encodings will be passed on to the diffusion model, and the diffusion model will start with the noise, that is the image will be full of noise, and slowly after the encoding is added on to the image diffusion, it will slowly transform into an output image. The output is a small image that reflects the caption we input to the text encoder, that is usually the of dimensions of 64 by 64. And the third step is the small image is then passed on to the super resolution model, which grows to a higher resolution, generally 128 by 128, and then the or 256 by 256, and then the result is a medium sized image of what we want. Then the final step is that the output from third step is passed on to another super resolution model, which operates the same way as the third step, and but this upscales the image to a high resolution image, so that we can clearly identify the image and evaluate it. So the next parts are the dives deep into the methodology by following each step of the implementation process. So here we have the first step, that is the text encoder. So the text encoder uses takes the input from the text prompt that the user or someone else provides, and analyzes the parts of the text or sentence, uh, and passes it on to the diffusion model. So here the Imagen uses diffusion model. Imagen uses text encoder network of T5 language model released by Google in 2019. So T5 uses text to text. T5 performs text to text analysis, and uh, based on the input provided by the user, the encoder ensures that the text encoding understands how the words within the caption relate to one another. So we it understands how the each part of the sentence relates to one another. This is very important, as it can without proper understanding, it can output images that are not aligning to the caption provided, and can obtain false results. And the text encoding understands the how the words within the caption relate with the process of self attention. So This is very important because there are a set of semantics to be followed in the English language, and this the T5 model will understand the semantics and encodes the text. The text encoder is frozen during the training, meaning that it does not learn or change the way it creates the encodings. It is only used to generate encodings that are fed to the rest of the model which is trained. So this means that it does not change the encodings beforehand. It is only upon receiving the input that it generates encodings, and the encodings are passed on to the diffusion model. So if we see other text to image models, we like OpenAI's DALI, we can see that it uses image encoder like a clip that compares the text caption and the images of several other data sets, and uses those text image captions to generate a new image, whereas the text encoder from Google uses only text, so it is trained only on text data sets. So to this can this provides opportunity to train on large text data sets instead of only image captioned data sets. This will improve the scope of training and generation of models. So, coming to the next part of the text to image model is the use of diffusion model. So, a diffusion model is a method of creating data that is similar to a set of training data. It trains the data by destroying the training data through the addition of noise, and then learning to recover the data by reversing this noising process. So here the diffusion model can start from a noise based image, and then upon the addition of the encoding, it can generate an image based on the parts of the encoding. So the encoding produced from the text encoder is a set of vectors. We then pool these vectors together and condition our diffusion model on them. So this means that the output from the encoding is can be considered as a set of vectors. So when we pool these vectors on and add them onto our diffusion model, it will try to generate images through at each time step. That is, for every time step, the the vectors can be added, and the noise will gradually reduce until the preferred image is formed. So the model is based on the unit architecture, that is on the grounds of CNN, that is convolutional neural networks, and the model learns the conditioning and adapts the denoising process to provide results aligned to the image caption. So at each time step, the model learns the conditions that are provided to it, and adjusts the noise process to provide an image that results in the alignment to the image caption that the user has provided. So here we can see the in the diagram that uh, the text encoding is split and understood semantically, and it is fed to the transformer, and that creates the encodings and applies it to the diffusion model. So at each step, the diffusion model will use these encodings and generate the required image. See, there are several other processes that happens during the image generation, and one other processes that happen are classifier tree guidance, increase fidelity, classifier free guidings that increase the fidelity. So that means the the classifier uses text inputs and does not and learns from them, and with the improvement in the guidance of the text input, it will increase the fidelity. Uh, that is the similarity between the reference image and the generated image. And uh, the diffusion the encoding the model also learns to how adapt to its denoising procedure by the conditions provided, and generates a well aligned image that is aligned to the caption. The next step in the Imagen is image super resolution. So image super resolution is the increase the upscaling of images uh, from the original generated image. So the base model of the image diffusion model outputs an image of 64 by 64 dimensions. So this will be difficult to see and identify through human evaluation. So to obtain higher images of higher dimensions, the image is passed through the diffusion model two more times, so that well-defined and a good resolution image can be obtained. So, as we saw in the flowchart or the overall model, we can see that the text encoding is applied on each of the diffusion model image generation and the super resolution image generation. And so it uses at both the steps of the resolution, it uses the diffusion model and the encoding provided by the text encoder to increase the dimensions and adjust to the changes that have been made by increasing the direction. So we also use the conditions on the smaller image that we are using to upscale. So the final upscaled image will be 1024 by 1024 resolution. And yeah, we can see that the the encoding and the images that is generated by the base model is applied throughout again, so that we can obtain a high resolution model. So coming to the results, the paper has provided certain results by comparing it to with current evaluated results. So there is no universal benchmark or evaluation system for image to text to image models, as it's an ongoing research. So Google has used the COCO dataset to evaluate text to image models, with FID used to measure the image fidelity, and clip used to measure the image caption alignment. So FID score will provide the similarity between the reference image and the image generated, and clip is used to measure the image caption alignment, which means the to check to measure how well the caption is aligned with the generated image. So Imagen achieves a state-of-the-art zero-shot FID of 7.27 on COCO, and which means it has outperformed other models that were trained on the same data set. It also achieves a preference rate of 39.2% for photorealism, which means it is more preferable than other generated images. This is based on the human rates that have who has given the human based evaluation ratings for the images generated, and it is also on par with the original reference images for caption similarity. So coming to the conclusions and limitations, we can see that these models have the potential to extend image editing capabilities, the it also improves the generation of art that can be unique and very creative, and this will lead to development of new tools for creative experts. And on the other hand, they can also be used for unethical practices and malicious purposes and bias. So this is a problem with artificial intelligence models where they are trained on where they are trained on models that are publicly available, and these data sets can have certain bias because it is human intention to generate bias in the data. It can include bias and other causes that can cause the training on this data, produce risk that can cause an impact by generating images that can have a significant representational harm on certain individuals and communities. So it is important to understand the results that can be obtained from the training the models using data from public sources. So it is important to train data from using good data sets, and uh, data sets that provide equality for the image generation. And yeah, so these are the references. The references are provide a great input to the paper, where techniques and uh, many techniques and processes and have been used into the creation of Imagen. Yeah, yeah. Thank you. And please drop a like if you like the video. Thank you.